Okay, video number 2. So we're just going to carry on and do the same things. We're looking for those 3 stipulations that have to be true for it to be a continuous graph. So what I'm going to do, so given this graph, we're going to look at point -1 and point 3. So point -1 first. We just want to go from the left and we want to go from the right. So I'm going to say the limit of f of x as x approaches -1 from the left. And what would that be equal to? So we're going up this way. It goes up by 2s, yeah, this is 2, yeah, so it's going to be equal to 2. And then if we go from the right, so now we're coming from that side, we're going to say the limit of f of x as x approaches -1 from the right is equal to what? It's equal to 0. It's approaching 0.
But wouldn't it be increasingly close to 0, but not 0?
Exactly. That's what approaching means. It means when you say approaching, we're not saying exactly what it is. We're saying what number is it getting closer and closer and closer and closer and closer to.
Yeah.
This kind of the circle kind of comes into part 2. So off the bat though, we get stopped right there, right? Because
the point doesn't exist.
This point doesn't exist. I'd say the limit of f of x as x approaches -1 is undefined. So I know right at the bat it's not continuous. If you want to too, we can see, does this point exist? Let's just do number 2, so we were aware. So number 2 for that one. 2. Does the point exist? So let's say f of -1.
It would be a circle if it existed.
It does exist though. There's a point there where f of -1 corresponds to a number.
Zero? 2?
2. F of -1 is equal to 2.
Which dot are we looking at?
Either one. We're looking at this dot because it's filled in, because that is the point right there.
Yeah, because that would exist at the bottom of this.
Yeah, but the point in general, this statement I made right here is true. F of -1 is 2 on this graph.
Okay.
Does that make sense?
Sure. No?
No? Okay. So let's go back. So the limit, so I guess comes down to the difference between limits and what the point actually is.
Actual real life application.
Well, limits are, they are. So the limit, so part 1 is talking about what number is the graph approaching. So like you said, as you infinitely get closer to this thing, what number does it start telling you it's getting closer to? Like if we got closer and closer and closer to this point, it's going to be there, right?
It's going to be 2.
Yeah. But from the bottom of this thing, as we get infinitely closer and closer and closer to -1 for x value, y approaches 0. So that's what the limits are, right? So in the end, we can't say that the limit of x is equal to -1 because it's, is it 2 or is it 0? This part though, for number 2, f of -1 is equal to 2. So if I look at this function and say this is really saying when x is equal to -1, y is equal to 2.
Okay, Again, it's just, why do they have I?
I don't know, yeah. Okay, so that's that one. So this point is undefined, or is not continuous, sorry, because, well, we were done as soon as part 1 came, because, there should be an x, because that doesn't actually work. Okay, so if we look at the second one here, yeah, let's do that. We say, so the limit of f of x as x approaches 3 from the left is equal to, what is that, 2, 4, 5. The limit of f of x as x approaches 3 from the right is 5. Yeah. So the limit of this thing is 5. It's from the left, from the right, we're good. This point also exists. So that's like 1, that's 2. The point also exists. F of 3 is equal to 5. And then 3, 5 does equal 5. You know, part 1 and part 2, they equal each other. The limit is equal to the point. So this thing does exist. So this next part down here, this is really just what we did up there. So
Yeah.
this is undefined. I'm just going to say UND. The limit of this is equal to 5. And we did this last part too. So this and this is what we did up top. So use the properties of continuous functions. The first one is not continuous. This one is continuous for the reasons we did up here. Okay, so for this one, I'm not sure if you remember seeing it written like this. This is just saying that like a function can be more than one function. It can be x squared and it can be 3 minus x. It just ends up looking like a wonky line. It just doesn't follow a smooth shape the whole time, right? So what this is saying is that f of x is equal to x squared if x is...
We have high school volunteers deliver our hot lunch to the elementary, please. High school students deliver our hot lunch to the elementary.
If x is less than or equal to 1. So when...
That would only be above the x-axis.
Yeah, so this is really saying when x is equal to like -2, that would work. When x is equal to -1, when x is equal to 0, and when x is equal to like 1. Those are all times when it would look like x squared. It's going to look like 3 minus x when x is equal to like 3 and x is equal to 2. So all I'm going to do here, so part A, is fill these points in so we can start graphing this. So when we have f of -2, well, -2 is, we're following the x squared formula, so that would just be -2 squared, so this is equal to 4. So we can plot that point right away. So -2, it's going to be up to 4, right? So it's going to be right there. -1 is going to be 1. So it's going to be like that. 0 is going to be 0 squared, which is equal to 0. So the point's going to be there. F of 1 is going to be, and it's a closed circle because
Greater than or equal to.
greater than or equal to. That's what's important. It's that greater than or equal to. So that's why it's a closed circle. And so that's going to be 1 squared is 1. So that's going to be right here. I'm going to make it a closed circle because that point is there. It's greater than or equal to that point. Okay, so that's kind of our first graph. Looks something like that.
Why is that a first graph?
Okay, and then f of 3. So 3 is using our second one, right? Using this now. So 3 minus 3 is equal to 0. So when we're at 3, we're at 0. So right there. F of 2, what was it again? 3 minus 2 is equal to 1. So when we go to 2, we're at 1. F of 1.01, well that's going to be 3 minus 1.01 is equal to 1.99. So that means we're getting really close to 2, right?
Yeah.
But we're never quite getting to it.
Yeah.
Because if we do an open circle, that would be, 3 minus 1, or like at f of 1, sorry. It's going to be 2, but it never is equal, it's not equal to 1. So the open circle is going to go right there. And we can see that this is gonna be the shape of our graph now, coming down like that. Okay, so we're gonna do just C here. So find the limits, if, we're gonna see if that's continuous now. So the limit of f of x as x approaches 2 from the left. So that's this point, right, 2? We're looking at that.
Okay, yeah.
So as it approaches 2 from the left.
That point exists.
Yep. And 2 from the left is approaching
Be 1.
1, right? Yeah. 1 from the right.
So 1.
1. It's 1. So this is good. So part number 1 here, if we were doing our thing, is good. The limit exists. Number 2.
Call lunch today is chicken ranch wraps.
F of 2 is equal to 1. So again, that checks out too.
Yeah.
And we also say, so for 3, 1 is equal to 1. The point matches the limit. So this one is continuous. So yeah, that's continuous. Okay, now for the last one here, quickly. We're looking now at this point. So as it approaches 1 from the left, that's going to be equal to what? Just 1. It's just approaching 1.
1.
So as it's approaching 1 from the right, it's approaching 2. So this is undefined. So right off the bat, 1's not met. It's not continuous. 1 not met. Not continuous. Alright, so that's it.